Okay. Now, first of all, we will have a quick recall for 5 minutes or maximum 10 minutes from the previous class. So in the previous class, we emphasized certain facts. Okay, first of all, we learned what is catechol group. Do you remember what is catechol group?
It's the two
Yes,
groups
it
of
is
OH
benzene
and attach the benzene ring in para position.
No, not
ortho.
so.
group
Ortho.
It's the benzene with the ortho hydroxyl group.
Yeah, two. So three thing you need to remember when you say catechol. First is benzene ring. Ring has to be benzene aromatic. Okay. Second thing is must be 2-hydroxyl. And third thing is 2-hydroxyl that are ortho to each other. So see, I have given you 3 examples here, which I did not give last class. So sorry. So you see, the first one is the catechol, right? Because it is ortho to each other. Second one is not catechol. Third one is also not catechol because the OH is para to each other. In the second example, the OH groups are meta to each other. So catechol means OH which is present ortho to each other. This concept is very important, as I said, in the whole chapter. Why it is important today you will understand. So I'm just trying to recall before I start with a new slide. Okay, then we have seen, okay, the two chemical messenger, that is noradrenaline, adrenaline, they belong to a class of catecholamines because they have a catechol group and also alkylamine side chain, right? Then we have seen the binding interaction of the adrenaline inside the beta adrenergic receptor. Now, can you quickly recall what are the points you need to remember from this binding interaction? How many types of interaction you see here?
I have 3 types.
3 or more?
4 types.
Okay, what are those? Tell me one by one.
The alcoholic, the hydroxyl group interactions, and the hydrophobic
No. See, you are
interaction.
messing up. See, answer it properly. My question was how many types of interaction? So bonding. So you cannot say alcoholic. Interaction means you have a hydrogen bonding. Yes, H bond. Yeah. Ionic bond,
Hydrophobic.
pi stacking interaction, and hydrophobic
and
interaction.
ionic
Yeah. Now you tell me, yeah. So for the four type of interaction, hydrogen bond, pi stacking, ionic interaction, and hydrophobic interaction, right? These are the 4 interaction you see inside the receptor. Now next question is, okay, which are the functional group shows hydrogen bonding?
OH.
Okay. How many OH is participating in the hydrogen bonding? How many types of OH and how many OH?
3.
3
See, I don't like this way of answering. I tell you why. Because you are answering very halfway. My question is how many types? I asked 2 questions. How many OH group and how many types? So when you say 3, it belongs to which question? 3 types or 3 number?
3 numbers, 2 types.
Exactly. This is the correct answer. Okay. So 2 types. Can you tell me how and what?
The phenolic
Okay, very good.
OHs and the catecholic OHs.
No, not catecholic. Phenolic itself is catecholic OH. The phenolic OH that is in catechol form. So you have seen if the phenolic OH means what? The OH group that is attached to the benzene ring. When the the phenolic OH they are in the catechol form, they can form 2 important hydrogen bonding with the serine 207 and 204. For the aromatic OH, okay, that is the phenolic OH, to form 2 hydrogen bonding, they must remain in the catechol form. Yes or not?
Yes.
Okay.
Yes.
Second type of OH is what? Tell me.
Alkyl.
Alkyl or alcoholic?
Alcoholic.
Alcoholic.
Yeah. So regarding the alcoholic OH, how many points you need to remember?
2 points.
What are those? Tell me.
Phenolic OH interactions and alcoholic.
My question was how many points you need to remember regarding alcoholic OH. I did not ask about phenolic OH.
It must remain above the plane in the form R enantiomers.
Very good. So for the alcoholic OH to form hydrogen bonding interaction with ASN 293, it must be in the R enantiomer, right? That means it must remain above the plane. If it is below the plane, it cannot form hydrogen bond interaction with ASN 293. Do you remember, all of you? That's why then we discuss between R and S, which one is active?
R,
Why R is active?
R.
because it's above the
Close the
plane.
OH above the plane.
Don't say it. Don't use this word. I tell you last class
OH.
also. Yes. So be specific. How
Alcoholic
do you
OH.
say? Okay. Yes. Why R is active again?
Because the OH is above the plane.
Wrong.
Alcoholic OH.
Yes.
The alcoholic OH. Okay.
Yeah, you see why it is wrong. Because there are three OH, two types of OH. If you say OH above the plane, doesn't make sense. Which OH?
No.
Yeah, you have to be specific. Osama is missing today. Okay, I think he's below the plane sleeping, probably. So I rectified him 3 times. So that's why I'm recalling again and again. These facts are important. Each and every point is important. So regarding OH, we have seen. Regarding aromatic OH, they must be, the key word is they must be in the catechol form to form, to be able to form two hydrogen bonding interaction with serine 207 and 204. Regarding alcohol OH, it must be in the R form to remain above the plane so that it can form hydrogen bonding interaction with the ASN 293. So these are about the hydrogen bonding. Then we have seen pi-pi stacking interaction. Do you remember how the pi-pi stacking interaction takes place? Here it is taking place between the benzene ring and the phenyl ring of the amino acid phenylalanine 290. What is pi-pi stacking interaction? Who remember?
Inside the ring, positive charge is formed, and on the
Okay.
outside there is a negative charge.
Why? What is
And
the reason?
because due to revolving.
Yeah, delocalization of the pi electron, right?
Yes.
So when two aromatic ring meet to each other, perpendicular to each other, you see here in this structure, I did not show this in the last class. In the green color picture, you see, when they meet like this, perpendicular to each other, so surrounding of one ring, periphery of ring with the negative charge faces the positive charge in the center of another benzene ring. That is how they get interacted. All right. Now coming to ionic interaction, where you see ionic interaction between? Look at the
Between
structure.
nitrogen and carboxylic group.
Yeah, between the
The
quaternary
terminal
nitrogen
nitrogen.
and the carboxylic group of the AsP113. Okay,
Yeah.
where you see the hydrophobic interaction?
The methyl.
Okay, how many points you need to remember? Let me see who remember this. This is the crucial point of discussion today's class regarding this methyl group, or we can say alkyl group.
Yes, the alkyl group is attached to the nitrogen, and it is the alkyl is responsible for the selectivity in the
Very
receptor
good.
pocket.
Yes. So alkyl group that is attached to the nitrogen atom, it is responsible for the selectivity of the drug. This is the first point. And second point, what type of interaction is shown by this alkyl group?
It's a
Hydrophobic
Hydrophobic interaction, because they reside fit into the hydrophobic pocket of the receptor. So regarding alkyl group, I quickly summarize. Regarding alkyl group, you need to remember 2 points. That is, alkyl group is responsible for the selectivity of the drug, and it shows hydrophobic interaction by inserting into the hydrophobic pocket of the receptor. Regarding the alcoholic OH, it is very important for potency, right? It must be in the R form. In the R enantiomer, it remains above the plane and able to form hydrogen bonding interaction with the amino acid ASN293, right? Then I told you a very easy way to remember in the exam. If I ask you which of the following enantiomer is more active pharmacologically, R or S, what is the clue to remember? I said, how many of you remember?
R is right, I think.
Yes, and then yes, R is the right answer. What is the another way?
This
What is
was
the name of the
alphabet.
chapter? Name of the chapter?
Oh, R for respiratory.
Yes, R for
Respiratory.
respiratory. So Kul R, right? R for respiratory, R for right answer. All right. So with this, we will move forward. Then we have seen the structure of adrenaline, where we have discussed there are what was the main or major disadvantage of the adrenaline. The adrenaline, the major disadvantage was it has poor oral activity. Okay, then let's go to the next slide. We discussed all this thing. So why my slide is not moving? Slide stuck. Okay. Now see, then the adrenaline analogs were developed due to three major drawbacks. Adrenaline was used for treating bronchospasm in asthmatic, but it was associated with three major drawbacks. What are the drawbacks? First of all, it has very short duration of action. It is short acting, could not be given prophylactically. Stay tuned. Don't leave your mobile and go to sleep, because I'll be asking in every slide a lot of questions. Okay. And secondly, it is inactive by mouth. So oral formulation is of no use. And the third important disadvantage is it is non-selective. Non-selective, why it is non-selective? Because of the presence of methyl group, which is the smallest alkyl group. Okay, this can, because this can bind to helps to bind to the alpha receptor as well as beta 1 and beta 2 receptor. Since this drug can bind to alpha receptor, it shows pressure effect, that is vasoconstriction, which occurs along with the vasodilation because it agonizes the alpha adrenoreceptor. It also switches on all possible adrenergic receptor, leading to whole range of side effects. That is, it shows cardiovascular side effect as well because of agonizing the beta 1 receptor. So see, now here in nutshell, you need to remember non-selectivity means it can bind to both alpha receptor, beta 1 and beta 2 receptor. Because it binds to alpha receptor, it shows the vascular constriction, that is the pressure effect. Because it binds to beta 1 receptor, it shows the cardiovascular side effect. Okay, whereas we need only to bind to beta 2 receptor to show the dilation effect of the airways. Okay, so there was a need for new analog to overcome this side effects or this problem. So how many problem you see with the adrenaline? Can you tell me how many problem?
The short effect
Okay,
and the
short acting.
non-selectivity.
Okay,
Non-selectivity.
okay, if I say totally 4 problems, first of all, it is short acting. We have not discussed why it is short acting. We will see. Secondly, it is inactive by mouth. Thirdly, okay, third, it shows pressure effect. Why it shows pressure effect?
Because non-selective.
Non-selective to what?
Because it's bound to alpha 1.
Beta 1 and alpha 2.
No, you are messing up. Listen question properly and answer. Why it? I did not ask why it is non-selective. My question was why it shows pressure effect.
Because affect alpha 1.
Because it's
Yes.
affect alpha 1.
Yes, because it activates the alpha. Okay. Now fourth one, why it shows cardiovascular side effect?
Because it's bound to
Agonizing
beta
beta
1
1.
agonist.
Beta 1. Okay. Yeah. So maybe I can make my slide a little more concise. Okay. For you to understand this slide, I will do this way. Just hang on. For you to understand, agonize. Does this make more sense? Okay. Now, does it make more sense?
Yeah.
Okay.
Yes, sir.
So how many problems you see? Short acting, inacting by mouth, and due to non-selectivity, it shows pressure effect. Why pressure effect? Because it agonizes the alpha adrenal receptor. Cardiovascular effect because it
Beta.
agonizes beta 1. Right. Right. So with this understanding, we will proceed with the chapter. Now our aim is to overcome all these 4 problems and develop a new drug or discover a new drug, okay, which by overcoming all the 4 effects. Now we know out of this 4 problem why there are 2 problems, that is why pressure effect and why cardiovascular effect. We know. What we don't know, why it shows short duration of action and why it is inactive by mouth. Right. So see, the short duration of action is because of the enzymatic degradation by an enzyme known as catechol or methyl transferase. You see the name of the enzyme itself, COMT, catechol or methyl transferase. What it does, it will convert the drug, okay, into an inactive form, which is known as 3-O-methyl adrenaline. If you look at the structure carefully, all of you listen carefully here. Okay, you see one of the OH group in the catechol group, which is mainly meta to the alkylamine side chain, it will convert this OH group into OCH3. Can you see the transformation? OH convert into
Yes.
OCH3. Okay, at the 3rd position, so we call it as 3-O-methyl adrenaline. Why? Because the methyl group added at the 3rd position. Start counting from the alkylamine. Okay, from here 1, 2, 3, 3-O-methyl adrenaline. Now here you remember 2 things very importantly. Wherever you see catechol group in this chapter in the drug, that means they will have the same problem. Okay, they will show the short duration of action because of the action of the enzyme COMT. And if I ask you a question in the exam, which of the following, okay, will have short duration of action? Give reason and draw the reaction. So see, the chemical change remains the same. Whenever you see the catechol, what you have to do, you just have to convert this OH group into OCH3. Is it clear, all of you?
Yeah.
Example of drug may
Clear.
change. Example of drug may change.
Yes.
It can be any drug. Moment you see catechol, what you have to do the change? The OH that is on the meta to the alkyl chain, you know, the alkylamine chain, you convert OH into OCH3. And the name also accordingly, you write 3-O-methyl. If it is adrenaline, adrenaline. If it is isoprenaline, then you will write O-methyl isoprenaline. And remember the name of the enzyme. So in a nutshell, the short duration of action is because of the action of the enzyme COMT, that is catechol or methyl transferase. So must remember how to write the name of the enzyme. All right. Secondly, the lack of oral activity is because of the formation of adrenaline or 4-O sulfate by an enzyme known as sulfokinase that is present in the gut. You know, in our gut we have an enzyme known as sulfokinase that can transfer or inactivate the drug by, you know, converting the second OH group. You see OH group that is para to the alkylamine group at the 4th position. It will convert OH into sulfate group. Can you see the sulfate group? HSO4. All right. If you cannot write it like this OH O2SO, you just write it as HSO4. HSO4, simple way. You can write like this. This is a shortcut, right? So here you need to remember the name of the 2 enzyme, which enzyme is responsible for what, and what is the chemical changes happening in the drug structure. So you see, when the sulfokinase attack to the catechol system, it converts the 4th OH into HSO4. Is it clear? The same, the example of drug may change, but whenever you see the catechol system, you understand that it may undergo attack by the sulfokinase in the respiratory drugs. Is it clear, all of you? Yes or not?
Yes.
Yes.
Okay. if I ask you a question here,
Doctor.
which of the following enzyme is responsible for short duration of action? Catechol O-methyl transferase or sulfokinase?
Catechol
Catechol
O-methyl.
Okay. Now, if I go to the previous slide again. Now, short duration of action is responsible for which enzyme?
Catechol O-methyl transferase.
Transferase. And what happens to the drug chemically?
Converted
OH.
catechol amine OH to
Uh-huh.
H3CO.
Oh.
OCH3. You see, in the name of the enzyme itself, it is there. Catechol O-methyl transferase. That means it transfers a methyl group to the oxygen. O-methyl. Okay.
Yes.
Oxygen to the methyl group. All right. Now, why it is inactive by mouth?
Because it's the conversion of OH by sulfokinase in the gut wall to the HSO4.
Very good. Which OH mainly undergo conversion?
The
Which
4
of the-
OH.
Yeah.
The third position.
No, not third. Fourth position.
Fourth
Fourth
position.
position.
OH, that is para to the alkylamine side chain. So now you know all the 4 reasons for the 4 drawbacks. Okay, first drawback is because of COMT. Second drawback is because of the sulfokinase. Third drawback, that is pressure effect, is because of the binding to alpha receptor. Okay, and fourth drawback, cardiovascular, because of the binding to beta 1 receptor. Is it clear? So how to remember? Yeah.
The first one about like catechol O-methyl transfers. Can you just say the mechanism again? It's convert. Just we're gonna say it's convert OH to COH3.
Yes, and make the drug in a short duration of action. It loses the. You see, when it converts into OCH3, it will not be able to form the hydrogen bonding with the receptor, and this drug is also found to be inactive. Okay.
Okay.
All right. So this concept, again, you see, these 4 concepts remain common. Example of drug will change, but the concept remain the same. Okay. So with this understanding, I am going to ask many questions now. Let me see who can answer. I go to the next slide. Now, to overcome this problem, they discover the ephedrine. Okay. Look at the structure. Don't read anything. Please give a chance to your mind. Look at the structure of ephedrine. How many advantages you see in this ephedrine and disadvantage?
No catechol amine. So it's with
How many advantages you can think of looking at the structure of ephedrine?
2.
As compared to adrenaline.
2.
Yeah, what are those?
Kind of 2. That is
No
an
catechol
oral
amines.
activity.
It is orally active. Why it is orally
And
active?
long
We don't have an OH on 4 position.
Number 3.
So it is orally active because it is stable to sulfokinase, right? Because it
Yes.
doesn't have catechol OH. And what is the duration of action?
It's going to be long.
long.
Why?
Because
Because
don't have
it is
an
stable
OH.
to.
OH is missing on position 4.
Yeah, not position 4. Don't mess up.
Position 3.
Okay. No, it is not the OH missing. It is the catechol OH. Remember again.
Okay.
It's a catechol.
Be careful. It is not. See, the enzyme name itself is catechol. If OH is present also, remember one point here. Even if the OH present, the OH, if it is in catechol form, then only it will be attacked by the enzyme catechol O-methyl transferase. See, in the name of the enzyme, it is there. If the OH is not in the form of catechol, it will not undergo attack by COMT. I go to the previous slide. You look at this. For the enzyme COMT to destroy the drug, okay, it must act on the catechol OH. If the OH is present like this, second and third example, it will not be able to deactivate the drug. Is it clear?
Yes.
All of you? Only one yes? How about the others?
Can you repeat?
I said, and what is the name of the enzyme? catechol O methyl transferase, right? Yes or no?
Yes.
So name itself
Yes.
it is there. When this enzyme will transfer one methyl group only to a catechol system. If the OH is present also, but if it is not in the catechol system, it cannot destroy.
Yes.
Are you getting my point?
Yes.
So
Yes.
see in the 3-ring system, all of them they have OH system, right? But the enzyme catechol O-methyl transferase COMT can only act on the first benzene ring because the OH is in the form of catechol.
Yeah.
The same enzyme cannot act on the OH group of the second benzene ring and third benzene ring. Why? What is the reason?
Because we say it's need to attack just the catechol OH. So when it's not in the form of the catechol, it's gonna not be attacking it.
Exactly. Because the orientation of the drug changes. Is it clear, all of you?
Yeah.
Yes.
So,
Yes, doctor.
so what you need to take out from your mind, it is not the enzyme attacking to the OH. It is not about presence or absence of OH. Okay, first doubt. Doubt number 1. It is not about presence or absence of OH. It is about if the OH is present, is it present in the catechol form? It has to be in the catechol form, then only COMT will attack. Okay. Same goes with the sulfokinase as well. So with this understanding, I go forward. So be attentive. Don't go away thinking that there is a recording. Now look at this. Now tell me how many advantage and how many disadvantage you see.
One disadvantage that the CH3 attached to the NH will bind to the alpha 1 and alpha 2, causing cardiovascular effects.
No. Cardiovascular because of alpha or beta 2?
Beta 2.
Beta 2.
Sorry, vasoconstrictor effect. The pressure effect. Yes.
Pressure effect because of alpha. So 2 side effect remain the same, right? That is, it will also show pressure effect. It will also show cardiovascular effect because it will bind to alpha 1 and also it will bind to beta 1, right? But what are the 2 advantages you see?
The
Long
log
acting
P
and
is high.
bioavailability orally.
Okay. Long acting and orally.
Oral active.
Okay. Now let me ask you a interesting question. What do you think? This drug ephedrine will be more active or less active compared to adrenaline, and why?
It will be more active because it has a high log P.
If I say low active, activity depends on binding with the receptor or availability inside the blood.
Binding to receptor.
Yes.
Yes,
Even if the
With
drug
no catecholamine, there is no H bond form in the site
exactly.
204, 207.
Yes. So even though it is available in the blood, so what happened? It will have less affinity compared to the adrenaline. Yes or not?
Yes.
Yes.
Do you
It
all
will lose
understand?
activity.
Yeah. So you see, even though you are able to overcome 2 problems, but again you are developing another new problem. What is the new problem? It is less potent. Okay. It has less affinity with the receptor as compared to adrenaline because it is not able to form 2 important hydrogen bonding interaction with the serine 207, 204. So you will see 2 hydrogen bonding less. Okay. So see, so there is another additional problem also. This is one problem, less active, and another additional problem. Because of the aromatic ring, you see, because of the removal of OH group, the drug become more lipophilic in nature. The log P increases. Because of the high log P, it can cross the blood-brain barrier and it can show the CNS side effect. So see, 2 advantage, but 2 additional disadvantage. Can you tell me now? if it's compared to the adrenaline, what are the 2 advantages and 2 additional disadvantages, and totally 4 disadvantages.
Yes, the 2 advantage is it's oral active due to not presence of catechol OH, and it's long acting. The disadvantage is the catechol OH not present, so it's prevent forming H bond with the binding site with serine 204, serine 207. And it's the presence of CH3 that attached to N make the binding with alpha 1 and beta 1, so can cause pressure effect and cardiovascular effect.
No, you missed the answer.
Yes, the about lipophilicity, it will cross brain barriers, so it causes CNS effect.
My question was what? What was my question?
What is the
disadvantage?
My question was, what is the 2 advantage and 2 extra disadvantages? What you answered is non-specific answer. You told all the
CH3. I shouldn't mention the CH3.
Yes, you
because
see,
it's both have it.
if you are in Philadelphia, you will get mark because we will look for the answer. But if you are in other good university, they will give you 0. Because always remember, answer to the point. The point is, what are the question was, what are the 2 additional disadvantage? What are the 2 advantage? The additional, you like a parrot. Don't be like a parrot. Blah 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 blah. Answer. Sometime when you know the answer, don't become excited. Think, take a pause, think and answer. Okay, so it's not your fault because you people are not habituated with writing the essay questions. So it comes with practice. Okay, so I request all of you think once before you answer. So it is clear now, right? So totally 4 disadvantage, but 2 extra disadvantages as compared to the adrenaline. So my question was, what are the 2 advantage and 2 additional disadvantages as compared to adrenaline? Because this is the way I ask question in the exam. I give a comparative, like in the anti-cancer agent, if you remember. Can you answer last time? Then I will go to the next. If you answer it here clearly, you will be able to answer in the next example very easily. Last try.
We can say the advantage, it's a longer lasting and oral activity, and the 2 additional disadvantage.
Give reasons.
What? I'm sorry.
When you answer, always give reason. Okay, I take a pause again. You will answer again. So remember, when you answer in chemistry, there is a difference between answering in pharmacology and answering in chemistry. If you say the same thing in pharmacology, you will get full mark. But in chemistry, you will get medicinal chemistry, you will get half mark. Because in medicinal chemistry, you have to give the chemistry reason. What is the reason behind? What chemical changes is happening? Okay, if you say it has a short duration reaction, you have to tell the reason. Okay.
Okay, so it's an oral activity because it doesn't have a catechol OH.
Very good.
And it's also longer lasting because it doesn't have a catechol OH in position 4.
Okay.
And the additional 2 disadvantage, it's that because it doesn't have a catechol group, it will not bind to the receptors, which will form an H bond with the serotonin 204 and serotonin 207. And it's also because it's have an aromatic, so it will be more lipo. It will have more lipo effect, so it's can cross the blood-brain barrier and cause some central nervous system effect like insomnia and other things.
Okay, whatever you said correct, but I would like to rectify again 2 things. Non-specificity. Don't use the word it. Always mention because of the lack of catechol OH catechol group. Okay, the catechol OH will not be able to form hydrogen bonding interaction with this one. Okay, so be this one, and again it's not lipophilicity. The log P increased. Okay, increased log P will allow the drug to cross the blood-brain barrier and show the insomnia. Now you can read the slides. Ephedrine was discovered, which did not possess the problematic catechol system. It showed similar effect, similar, not same, to adrenaline. It was longer lasting. You see the keywords longer lasting and orally active, but it was not as active as adrenaline. You know the reason why, right? It is not as active as adrenaline because of the lack of cortical OH, which was required to form important hydrogen bonding interactions with serine 204 and 207. Also, increased LOCP allowed the penetration of the drug across the blood-brain barrier, which resulted in insomnia. However, the pressure effect, it continues, right? What happened to the pressure effect? Will it show?
It will occurs.
Continue. We have it.
It's
Will
well
it show?
present.
Yes, yes. So now you can say it will also show the pressure effect. It will also show the cardiovascular effect, same as adrenaline, because of the presence of
CH3.
It's the methyl on the N group.
Yeah, because of the presence of methyl group attached to the nitrogen atom. So to what they did, they discovered then isoprenaline. Look at the structure of isoprenaline. Now think, don't read anything. Think. What advantage you see in the isoprenaline? What is the structural changes you see in the isoprenaline and ephedrine? How many structural changes?
Propyl.
Methyl is changed with the isopropyl
So
group.
it will change the lipophilicity.
There is the two OH groups that have been attached.
These two
They're
OH group
different.
is catechol or not a catechol?
Catechol.
Yes. So catechol system is brought back to increase the potency. Okay.
Okay.
So if I ask you, based on you see there are two structural changes. Methyl changed to isopropyl and catechol group is introduced. Now, if I ask you, now listen my question carefully. Okay. What is the advantage you see as compared to ephedrine?
We can say it will not have any like cardiovascular effect or pre-associated effect.
CNS effect. Side effects.
No, not
Because the
cardiovascular.
presence of isopropyl.
Yeah. So isopropyl is bigger than alkyl. So here I will go to another slide before then I'll come back. Now look at this slide, all of you. I have drawn this for you. This is not there in your lecture slide. To make you generally I explain it in the class face to face, drawing in the board. Now listen to the third concept and the last concept of the class of this chapter. You see the hydrophobic pocket of alpha receptor is smaller as compared to beta 1, whereas hydrophobic pocket of the beta 1 is bigger as smaller as compared to beta 2. In other words, hydrophobic pocket of beta 2 is bigger than beta 1, beta 1 is bigger than alpha. Is it clear? All of you are with me?
Yes.
Yes.
You can see the size of the pocket. So what happened? If it is a small alkyl group like methyl, you see, because it is small, it will fit to all the pockets. It can fit to smaller hydrophobic pocket of alpha, beta 1, bigger pocket of beta 1, and even bigger pocket of beta 2. That is why it shows non-selectivity and it will show all the side effects. Now, when you change the methyl to isopropyl, isopropyl is bigger enough that it will not fit into the alpha receptor, alpha hydrophobic pocket. Do you understand what I said?
Yeah.
So it will show no pressure effect.
Yes. So isopropyl, it will not show pressure effect, but isopropyl can bind to both beta 1 and beta 2.
Beta 2.
Yeah. So what is the side effect you will see if it is isopropyl?
A
Cardiovascular side effect.
Cardiovascular. So the drug that is having isopropyl, it will still show cardiovascular side effect, but it will not show advantages. It will not show pressure effect. But when you change from isopropyl to tertiary butyl, you see the bigger alkyl group, tertiary butyl.
More selective.
Yeah,
No
tertiary
pressure.
butyl group. Yeah, it will bind only
No
to
pressure, no cardiac. You only see the respiratory side effects for the beta 2.
Yeah, so Not side effects. Be careful with your words. No respiratory side effect. Don't say respiratory side effects.
Well, if you don't intend it for beta 2, then it will be a side effect.
What? Side effect?
If you don't intend the therapy for beta 2, then it's a side effect, right?
Don't try to be over smart. Okay. Talk to the contents. You don't have to win me by wrong way of answering. Okay. Don't take it to your ego when I say something. Cut down your ego and be in the class. So tertiary butyl means it will bind only to beta 2 receptor. So advantage, when you see tertiary butyl and bigger than tertiary butyl, it will not show cardiovascular side effect, and also it will not show pressure effect. So with this, we go to the previous slide. Okay, now look at the structure, isoprenaline. Apply your concept. Tell me, listen my question. Don't be excited and answer. Okay, it's good to be excited, but control. Okay, listen my question. How many advantage you see? Okay, advantage of isoprenaline as compared to adrenaline, not ephedrine. How many advantage?
One advantage.
CNS effect.
Two advantage.
Two.
It does not penetrate the blood-brain barrier, and it's beta selective. Does not have any pressure effect.
No, I said compared to adrenaline.
One advantage.
One advantage.
Only one.
More selective.
What is that? Yeah. Tell
It's
what
like
is the
doesn't
one
have a preceding side effect. It just connect to the beta receptors.
So compared to adrenaline, it has only one advantage. That is, it does not show pressure side effect.
Yeah.
But how
What
many?
about the CNS side effect?
Wait. First, you answer my question. How many common disadvantage you see as compared to adrenaline?
We lose connection. I didn't hear you.
It's not oral activity.
How many common disadvantage as compared to adrenaline?
Two, the duration and the oral bioavailability.
How about the others?
And a beta side effect.
Yes, now this guy is still stuck to the side effect. Yeah, now we can speak about your side effect. Yeah, what is that? Yes, Osama? You said something?
I said they missed the beta side effect with alongside the others. It's short acting with the oral, short acting orally not available, and the beta side effect. That's
What
common
is
between.
beta? Which beta? There are two betas. Beta 1, beta 2. Which one?
Beta 2.
No.
Beta 1. Beta 1. Sorry.
So it will also bind to side effect because it will also bind to
beta 1.
Beta 1 receptor. And what is the side effect?
Cardiovascular.
Okay, so it will also bind to the hydrophobic pocket of the beta 1 receptor of the heart, and it will show cardiovascular side effect, right? So when you compare this drug isoprenaline with adrenaline, you see only one advantage, that it does not show pressure effect, but you see three common disadvantages: short acting, orally inactive, and cardiovascular side effect. Now my next question: how many advantage and disadvantage you see as compared to ephedrine? How many advantage?
Two advantage.
Two?
More two advantage.
Yeah, two advantage.
One.
Okay. Oh, yes, somebody said something for? Two or four?
What 2 or 4?
Okay, I repeat my question. How many advantage you see? How many advantages of isoprenaline as compared to ephedrine?
Is that 3? We can say
it does not have the pressure effect that
okay, I bring the structure. I bring the structure here. This is the structure of ephedrine. Look at both the structure together. Now tell me, how many advantage you see advantages of isoprenaline as compared to ephedrine?
3.
Like I
What are those?
It does not have the nitrogen attached to Okay.
We can say it is gonna
Still has the pressure effect. No.
Which one?
No pressure effect. It does not
The
have pressure effect.
Proline.
It's 3 advantage. The first advantage is the more potency.
Very good. Why it is more potency? More
we
potent?
have a catechol group.
Because catechol. And
Okay, complete. Catechol group, so what? Continue. Tell the complete story.
What?
Tell the complete story.
Yeah.
It has catechol, so what?
So it will bind the receptors of and
It
form
can make hydrogen bond to the receptors.
certain to 0.07.
Yes.
Yeah.
So isoprenaline, because it is catechol, it will form two important hydrogen bonding with the amino acid residue serine 207 and 204 of the receptor. So if you only say it will form hydrogen bonding, it is incomplete. There are many amino acid. With which amino acid you need to be specific. Okay. So this is one advantage, potency. What is the second advantage?
More selective.
It is more selective to what?
To
beta
receptor. Beta 1 and
beta as compared to alpha. So what is the story? Continue.
It's not the pressure effect because not alpha agonized.
Yes.
Okay,
It will not show pressure effect because it will not bind to the alkyl group. The bulky isopropyl group will not bind to the smaller hydrophobic pocket of the alpha receptor. What is the third advantage? Third advantage?
It's not blood-brain barrier penetration. So no CNS side effect.
So no CNS side effect. So it will not cross because it has less log P. It will not cross the blood-brain barrier. It will not show CNS side effect. Is it clear?
Yeah.
Okay. So now you can read the slide. All right. So isoprenaline was made with isopropyl group attached to an atom of adrenaline. It has reduced log P, so no blood-brain barrier penetration, no insomnia. Okay, so it was only selective to, it is only selective to beta, that is beta 1 and 2. So no pressure effect, no pressure side effects because it does not bind to alpha, right? But it will still show. What is the common side effect you will see?
Cardiovascular.
Cardiac side effect.
Cardiac side effect. Okay, so how many common side effect of isoprenaline as compared to adrenaline?
It's one.
I can't think of any besides the cardiac side effect.
How many common drawbacks or disadvantages of isoprenaline as compared to adrenaline?
We say one.
How many
They are
disadvantages?
both orally not available, both short acting,
yes,
and both have cardiac side effects.
Yes, so three. There are three disadvantages common between adrenaline and isoprenaline. Okay, both of them short acting, orally not active, and both of them shows cardiovascular side effect. Is it clear? Okay, good. And the reason, because you see the hydrophobic pocket of beta is bigger as compared to the hydrophobic pocket of alpha. So in the smaller pocket, methyl group can fit. Methyl group can fit into smaller pocket and bigger pocket, but the bulky isopropyl group cannot fit into the smaller hydrophobic pocket of the alpha receptor. Okay. So isoprenaline, it was shown to have promise in asthma, treatment of asthma, and it was beta selective, so no pressure side effect. But it caused many deaths due to aerosol overdose on heart because of the beta 1 agonism, right? And also had catechol, which is vulnerable to COMT and sulfokinase, same as adrenaline. This observation highlighted the need to find substitute for catechol system. So with this slide, I think better I will finish my lecture here. Next class I will continue. So is it clear so far, whatever we discussed today?
Yes.
Yes.
Yes, of course.
Okay, so I'm going really slow. I hope you will appreciate this, that I'm going slow. I could have finished the chapter very fast, ensuring each and every slide that you understand. before I go. And I hope you are enjoying also when I ask questions. Now we have, I think, 10 minutes time. Can I ask some more questions?
Go ahead. We appreciate that. Yeah.
Okay. In that case, I should have prepared some more question in advance. Anyway, let me ask. How many common side effect? What is the common side effect between adrenaline, ephedrine, and isoprenaline?
The cardiac side effect.
The cardiac side effect.
Cardiac side effect. Why?
They all
Because they all bind to the beta 1
and agonize it, so it makes the cardiac side effect.
Okay, it will show the cardiac because all of them can bind to beta 1. Which one will bind to alpha and why?
Ephedrine
and
because
adrenaline.
Ephedrine
and
and
adrenaline.
adrenaline.
Why?
Because they have a methyl group attached to N, so it will fit the pocket of alpha receptors.
Why? What you said is absolutely correct. Can you say it little clearly with bit explanation?
Like we can say, like alpha bucket is more smaller than beta.
Exactly.
They are less hydrophobic, so more hydrophilic, making them available to bind to alpha receptors.
It's not about the hydrophilic or hydrophobic, it's the size. Remember in the beginning, I said, it is the
smaller.
Yeah, remember I say it is the size of the alkyl group here. If you remember the 2 point I said, now you understand the reason for 2 point I said regarding the alkyl group. 2 point, the size of the alkyl group decides the selectivity of the drug. And secondly, the alkyl group binds to the hydrophobic pocket, shows the hydrophobic interaction. Now you understand, right? We have 3 examples today, how the size affects the selectivity. Is it clear? So you have to mention when you write an answer, especially medicinal chemistry answer, okay, the reason. Pharmacology, you can simply say without reason, because pharmacology you do not discuss or talk about the medicinal chemistry. This is why you are studying in medicinal chemistry, to know which functional group of the drug is responsible for which type of, how it influences the activity, side effect and everything. And when you know, this is the reason why you study medicinal chemistry. It gives you depth insight, understanding about the drug, and helps you to develop or discover a new drug. And this is what we call it as structure activity relationship studies. Structure SAR. We are studying the SAR, like how the structure of a drug is responsible for particular activity. Okay, either to increase the activity or to decrease the activity. When we say activity, it can be side effect as well. All right. So regarding catechol, to sum up, we have seen regarding catechol, how many point, if I can ask you here, how many point you need to know regarding catechol?
The potency.
Yes, very good. And
the oral availability.
Yes, very good.
And short acting or long acting.
Yes. So regarding catechol, I did not ask this in previous class. I said regarding alcoholic OH, how many point? 2, right? It must be above the plane and to form the hydrogen bonding. Otherwise, the potency will decrease. But the potency is influenced mainly by the alcoholic OH as compared to the catechol OH, right? And catechol OH, you need to remember 3 points: the binding interactions, then oral availability, and short duration of action. Okay, duration of action. What are the name of 2 enzymes that are responsible for oral bioavailability and short and the duration of action?
Catechol or methyl transferase and sulfokinase in the gut wall.
Sulfokinase. What are the structural changes you see?
In the catechol or methyl transferase, we transfer a methyl.
Okay, so the OH that is at the 3rd position, it will convert into, what is the structural changes you see?
Becomes OCH3.
OCH3. And when the sulfokinase attack, what happens?
It adds HSO4 to the 4th position.
fourth position of the fourth OH group, right?
Fourth OH group becomes HSO4.
Yes, very good. So these two structural changes, you will see it common, okay, both in case of adrenaline and also in case of isoprenaline. So wherever you see this catechol, okay, you can imagine, like, you can expect the same two structural changes. Example remain, the concept remains same, but example changes. So in this class, we studied two concepts. One concept is regarding the duration of action and oral availability, and third concept we have seen about the selectivity, how the selectivity is influenced by the alkyl group. So always, if you remember this concept, you can answer actually any questions and you will understand all the drugs, action, side effect, etc. So with this understanding, I will finish my lecture here. If you have any doubt, you can ask me.
What was the 3 points regarding the catechol?
Okay, 3 point. You see the hydrogen bonding interaction with the serine, first point. Second point is duration of action. Okay, duration of action, which is influenced by catechol-O-methyl transferase. And third point is sulfokinase, oral bioavailability. Do you understand? Catechol OH will be undergone attack by sulfokinase. These are the 3 points.
Got it.
Okay, any other questions? So like this, I will play around. I will give you many structures in the exam and I'll ask you what is the advantage of this as compared to this, what is the disadvantage of this as compared to that one, like that. So if you know this concept, you can answer any questions, right? So I will end my lecture here.
Can you, like, the functional groups, like you will get one with a charge. So
I will give you, don't worry. And don't miss my workshop. After finishing this chapter, I will also give a workshop on this chapter exclusive.
So that will be included in the workshop.
Yes, I will give a lot of questions. Okay, now you
just
see.
wondering.
Yes, I will give. Don't worry. In my subject lecture, this is the special thing you get. I give workshop continuously. Okay, after every chapters, and where I ask a lot of structured questions. And when you answer again and again, you become more clear. Right. So I finish my lecture here today. If you have no other doubt, and any doubt regarding your quiz in the next class.